Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on probability. If you need any extra help in probability, if you go to Corbettmaths and go to the videos and worksheets section and watch video numbers 244, 245, 250 and 251, there's dedicated video tutorials there on probability. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at our first question, question number 1. So question number 1 says the diagram shows a fair spinner. So we've got here yellow and blue. And part A says which colour is the arrow most likely to land on. So if this arrow is spun, which colour is it most likely to land on? So it's most likely to land on yellow rather than blue because as you can see this sector is a lot bigger than this one. So the answer would be yellow there. And then part B says mark the scale with an arrow to show the probability of the spinner landing on green. So we've got this probability scale here with 0 at one end and 1 at the other. So remember 0 is impossible, 1 is certain, and in the middle there would be even chance. And we want to mark where the probability would be of the spinner landing on green. Now there is no green, so it's impossible. So that means that the arrow would point at 0. The arrow would point here, it's impossible. So that would be the probability of it landing on green there. Okay, let's look at our next question, question number 2. So question number 2, we've got some words here, impossible, unlikely, even, likely and certain. And the question says which word from the box best describes the likelihood of each of the following events. And part A says a newborn baby is a girl. So obviously a newborn baby can either be a boy or a girl and there's an even chance of either of them. So we're going to write even chance there. There's a 50-50 chance, even chance. And we say even chance rather than 50-50, but it's an even chance. And then part B says you roll an ordinary dice or throw an ordinary dice and you get a 2. So on an ordinary dice is 6 numbers, 1, 2, 3, 4, 5, 6. Getting a 2, well there's only 1 2 on the dice out of the 6, so it would be 1/6, so it's going to be unlikely. It's not even chance, it's not equally likely you're going to get a 2 and not a 2. It's not impossible, so it's going to be unlikely. So it's unlikely. You might get it, but it's unlikely. Okay, let's have a look at our next question, question number 3. So question number 3, we've got the same words again here, impossible, unlikely, evens, likely and certain. And we've been asked to choose a word from the box that best describes the probability of each of the following events. You roll a 10 on an ordinary 6-sided dice. Well, a 6-sided dice is the numbers 1, 2, 3, 4, 5, 6. A 10, but that's not on the dice, that's going to be impossible. It's impossible. And then part B says you roll a number greater than 1 on an ordinary 6-sided dice. Well, on the dice, you've got the numbers 1, 2, 3, 4, 5, and 6. It says you roll a number greater than 1, so that's either that one, that one, that one, that one, or that one. So it's going to be likely. You're likely to roll a number that's greater than 1 on a dice. You may roll a 1, which is obviously equal to 1, so that wouldn't be greater than 1. So it's going to be likely rather than certain. So it's going to be likely. Okay, let's look at our next question, question number 4. So question number 4, we've got this dice here and it's an ordinary 6-sided dice and it's thrown. And it says the probabilities of the following events have been marked on the probability scale below. So we've got this probability scale with 0, that's impossible, 1 is certain. And we've got these 3 arrows here, here and here. And we've been asked to place events A, B and C into the correct boxes. So we need to put A into one of these boxes, B into one of these boxes and C into one of these boxes. Okay, so let's have a look at the event. So event A is a number less than 7 is thrown. Well, it's an ordinary 6-sided dice, so when you roll a 6-sided dice, you're always going to get a number less than 7. So that has to happen. So A is going to be certain, so it's going to go there because that's going to be a probability of 1. If something's got a probability of 1, it's certain to happen. Okay, we've got 2 more events left. A 6 is thrown. Well, if you roll a 6-sided dice, well, there's 1 6 on the dice, so that's going to be 1 out of 6. If the probability of you rolling a 6 on a dice would be 1/6. So it's unlikely you get a 6. So for instance, if I had a dice and I say I'm going to roll a 6 and I roll it, it could happen, but it's unlikely that you will. So the probability of a 6 being thrown would be here. It's going to be there, so it's going to be B. The probability of rolling a 6 would be unlikely, so it's going to be there. Okay, and then we've got 1 more event and 1 more arrow. Let's just check this one's right. So here we're in the middle here, so this is even chance. And event C is an odd number is thrown. Well, if you roll a dice, 3 of the numbers are even. They would be 2, 4 and 6, and 3 of them are odd, 1, 3 and 5. So that would be there. So yes, C would go there to get an even chance of happening. So you've got an even chance of rolling an odd number on a dice. And that's it. Okay, let's look at our next question, question number 5. So question number 5 says a mirror makes a fair spinner with 6 sections. So it's got the spinner, it's got 6 sections and they're labelled 2, 3, 3, 3, 4 and 5. And then we've got this box with some words, impossible, unlikely, evens, likely and certain. And then we've been asked to choose a word from the box to best describe the probability of each of the following. So part A, the spinner will land on a 6. So let's have a look here. There's no 6s on the spinner, so that's going to be impossible. So let's write that down, impossible. Okay, then part B. Part B says the spinner will land on a 3. Well, on the spinner, there's 6 sections, as we were told, 6 sections, or we can count them, 6 sections, and 1, 2, 3 of them have got a 3 on them. So that means that half of the sections have got a 3 on them. So that means that it's an even chance. You're as likely to get a 3 as not a 3. So it's an even chance. So let's write that down, evens. And then part C. Part C says the spinner will land on a 2. So if we go up here, the 6 sections, there's only 1 2, so there's only 1 out of the 6 possible sections that will give us a 2. So that's going to be unlikely. It's not impossible because there is a 2, but it's obviously not even chance or likely or certain, so it's going to be unlikely. So let's write that down, unlikely. And then the next one, part D. Part D says the spinner will land on a number greater than 1. Well, all the numbers are greater than 1, so that's going to be certain. It has to land on a number greater than 1, so that's certain. And that's it. So we've done that question. Okay, let's have a look at our next question, question number 6. So question number 6, we've got this probability scale, and we're told that a fair 6-sided dice is rolled, and we're told the probability of one of the following events is marked with an arrow on the probability scale below. So this represents one of these events. And part A says, label the arrow to show which event it is. So is this event A, event B, or event C? So if we have a look here, it's got 1, 2, 3, 4, 5, 6 little marks. So obviously that makes sense in terms of a dice. So this would be 1/6, 2/6, 3/6 or a half, 4/6, 5/6 and 6/6. So this one here, we've got, in terms of our 3 events, we've got the dice will land on a number that is less than 3. Well, that would only be a 1 or 2. So that would be 2/6 because 2 out of the 6 have got numbers less than 3. B, the dice lands showing the number 3. Well, there's only one number 3 on the dice, so that would be 1/6. So only one of the 6 possible outcomes would work there. And event C. Event C says the dice lands showing an even number. Well, there's a 2, a 4 and a 6. And that's 3 of the possible outcomes. 3 of the 6 of them. So that'd be 3/6 or a half. So that's going to be event C. That would be event C. It's an even chance of getting an even number when you roll a dice. Okay, and then part B. Part B says mark and label the scale to show the probabilities of the other 2 events. So we need to show A and we need to show B on the probability scale. So in terms of A, the dice lands showing a number less than 3. Well, there's 2 numbers less than 3 on a dice, a 1 and a 2. So that's 2 out of the possible 6. So we're going to put an arrow here to 2/6 there. So that would be event A. And then event B says the dice lands showing the number 3. Well, there's only one number 3 on the dice out of the 6. So it's going to be 1/6. So it's going to be here, 1/6. So that would be event B. And that's it. So that's event B, that's event A, and that's event C. Okay, let's look at our next question, question number 7. So question number 7 says the following cards are placed in a box. So we've got the cards 1, 2, 3, 4, 5 and 6. And a card is selected at random. And we've been asked to find the probability that the number on the card is a 3. Well, there's 6 possible cards and one of them's got a 3 on them. So the probability of getting a 3 would be 1 out of the 6. So 1/6. And then the next one, part B. Part B says an odd number. Well, there's 1, 2, 3 odd numbers out of the 6 cards. So that would be 3 out of 6 or 3/6. Now we could write our answer as 3/6 here if we wanted to. It doesn't say we have to cancel it down, but I noticed that 3/6, if you cancel it down, would be 1/2. If you divide both the numerator and denominator by 3, you get 1/2. So the probability of getting an odd number whenever you select one of these cards at random from the box would be 1/2 or 3/6. And that's it. Let's have a look at our next question, question number 8. So question number 8, we've got this spinner and it's got 8 equal sections and they're labelled A, B, B, C, D, E, A and A, or A, B, B, C, D, E. And then we're told the arrow is spun and part A says which is the most likely letter that the arrow would land on. Well, which is the most likely letter that the arrow is going to land on? Well, if we have a look at it, there's 3 A's, there's only 2 B's, 1 C, 1 D and 1 E. So A is going to be the most likely letter that the arrow is going to land on. And then part B says what's the probability that the arrow lands on a B? Well, there's 8 sections, there's 2 B's, so that's going to be 2 out of the 8 or 2/8. So the probability that the spinner lands on a B would be 2/8. Now you may notice that I wrote that here rather than there, just because I noticed that that fraction 2/8 can be cancelled down. Both the numerator and denominator are divisible by 2, so I would write 1/4 there, dividing both the numerator and denominator by 2. Now you don't have to cancel it down, it didn't tell us that we had to cancel it down in the question, but I tend to cancel it down if I can. Okay, and then part C. Part C says, what is the probability that the arrow will land on an A? So let's go up here. There's 8 sections, 8 equal sections, and there's 1, 2, 3 A's. So it's going to be 3 out of 8, or 3/8. So let's write that down. 3/8. That's the probability that the arrow will land on an A. Okay, let's have a look at our next question, question number 9. So question number 9 says, Thomas has got 12 cards, each with a letter on it, and they spell out Corbettmaths, and he picks a card at random. And the question says, write down the probability that the chosen card is the letter H. Well, there's 12 cards, like we're told. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the letter H, well, there's 1 H. So it's going to be 1/12. 1 out of the 12 cards. And then B, we've been asked to find the probability that the chosen card is the letter T. Well, if we have a look here, in terms of the cards, there's 12 cards. And now I just count the number of T's. Well, there's 1, 2, 3 T's. So that means the probability of picking a T would be 3/12. Now here, 3/12, that can be cancelled down. Both the numerator and denominator are divisible by 3, so that would be 1/4. And again, you don't need to cancel it down here. It doesn't tell us we had to do it in the question, but I would tend to do it if I can. And then part C. Part C says not the letter E. So let's go up here, not the letter E. So if we want to find out the probability of not getting the letter E, well, that would be all the other letters apart from E. So it would be that one, that one, that one, that one. Well, that is E. That's not E, not E, not E, not E, not E, not E, not E. So it's going to be 11 out of the 12. So 11/12. So 11/12. Okay, the next one, part D. Part D says the letter B or the letter T. So the letter B or T. So let's go up here. So we want to find the probability of picking a B or T. So let's rub those out. And we're looking for B's or T's. Well, there's a B, there's a T, there's a T, and there's a T. So altogether, there's 4 B's and T's out of the 12 possible cards. So that means the probability of picking a B or a T would be 4/12. So let's write that down. 4/12. Now again, I've written that one there just because both 4 and 12 are divisible by 4. 4 divided by 4 is 1, and 12 divided by 4 is 3. So that means the probability of picking a B or a T would be 1/3. And again, you can write 4/12 if you wanted to. The question didn't say you had to cancel it down, but I tend to cancel it down if I can. Okay, and then part E. Part E says the probability of picking a vowel. Now, you probably wouldn't have a GCSE question like this where it says find the probability of picking a vowel, because I don't think they would assume that you know what the vowels are, even though you probably should know what they are. They are A, E, I, O, and U. So we want to find the probability of picking any of those letters. So let's go up here and find where the vowels are. Okay, so let's go through. Well, O's a vowel, E's a vowel, and A's a vowel. So there's 3 vowels there out of all the letters, the rest are consonants. So that means that there are 3 vowels, so 3 out of the 12, 3/12. And again, that can be cancelled down because both the numerator and denominators are divisible by 3, so that would be 1/4. So the probability of picking a vowel would be 1/4, and that's it. Okay, let's have a look at our next question, question number 10. So question number 10 says a bag contains 10 discs, and each of the discs is labelled from 1 to 10. And a disc is picked at random from the bag, and we've been asked to find the probability that the chosen disc is the number A. Well, there's 1 3 in the bag because they're labelled from 1 to 10, so there'd be 1 1, 1 2, 1 3, 1 4, and so on. So there's 1 3 out of the 10 possible discs. So the probability that a 3 is chosen would be 1/10. And then part B. Part B says a number less than 4. Well, a number less than 4, will that be either a 1, a 2, or a 3? They're the numbers that are less than 4. So in terms of the discs in the bag, there'd be 3 possible discs that would work out of the 10. So that'd be 3/10. Okay, next, a square number. Well, let's consider our square numbers. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and they're the square numbers, so there's 3 square numbers, so that would be 3 out of 10, so 3/10, because there's 10 discs going from 1 to 10, and a 1, a 4, or 9 would work, so that would be 3/10. Okay, next, a prime number. So the prime numbers are 2, 3, 5, 7, and then 11, which obviously is not in the bag. So out of the possible discs in the bag, the 1 to 10, there's 4 numbers that would work. There's 4 prime numbers, so that'd be 4/10. Now that can be cancelled down. Both the numerator and denominators are divisible by 2, so that'll be 2/5. So that's it. So that's the probability of getting a prime number, 2/5. Okay, let's look at our next question, question number 11. So question number 11 says, Liam rolls an ordinary fair 6-sided dice. So he rolls a dice and we've been asked what's the probability that he gets the number 4. Well, there's one 4 on the dice out of the 6 possible numbers, outcomes, 6 sides. So it's going to be 1/6. And then part B says, find the probability that he gets a number less than 5. So that'll be a 1, a 2, a 3, or a 4. There's 4 possible numbers there that are less than 5 out of the 6. So that'll be 4/6. Now that can be cancelled down to be 2/3. So the probability of getting a number less than 5 would be 2/3. Okay, let's have a look at our next question, question number 12. So question number 12 says, Katrina's got 10 yellow counters, 5 orange counters, and 4 white counters. And one of these counters is chosen at random. And we've been asked to find the probability that the counter is orange. Well, let's find out how many counters Katrina's got altogether. So let's add together 10, 5, and 4. And that'll tell us how many counters Katrina's got. So 10 plus 5 is 15, plus 4 is 19. So there's 19 counters altogether. And the probability that she picks an orange one would be, there's 5 orange counters, it'd be 5 out of the 19 counters. So that'll be 5/19. And that's it. That's the probability that Katrina chooses an orange counter, 5/19. Okay, let's look at our next question, question number 13. So question number 13 says, there's 12 chairs in a room, so there's 12 chairs in a room, and 5 of the chairs are brown. And the question says, the chair is chosen at random from the room. Part A says, what's the probability that the chair is brown? Well, 5 out of the 12 chairs are brown, so the probability of picking a brown chair would be 5 out of the 12, so 5/12. Now, if we carry on, we're then told there's only red and green pens in a box. And a pen's chosen at random from the box, and the probability that the pen is green is 0.6. Because remember, the probabilities can be given as decimals and percentages as well as fractions. So here we've got the probability as a decimal. So it says the probability that the pen is green is 0.6. And we've been asked to find the probability that the pen is red. So that means, because we're told there's only red and green pens in the box, that means it's either going to be red or green. It's one or the other. So if the probability of it being green is equal to 0.6, the probability that it is red would have to be 0.4, because they have to add together to be 1. It's certain that you're going to pick one of the two colours. So that means if we want to find the probability that it's red, you just do 1 take away the probability that it's green. So you do 1 take away 0.6, and that's equal to 0.4. Or you just figure out what you would add to 0.6 to get 1, which would be 0.4. And that's it. So in this question, we knew that there was red and green pens in the box. We knew the probability of it being green is 0.6. So that means the probability that it's going to be red would have to be the rest of the possible outcomes, which would be 0.4. Okay, let's look at our next question. Question number 14. So question number 14, we're told there's 50 sweets in a bag, and 13 of the sweets are lemon flavoured, and the rest of the sweets are strawberry flavoured. And we're told that one sweet is taken at random from the bag. We've been asked to calculate the probability that the sweet is strawberry flavoured. Okay, so we know there's 50 sweets in the bag altogether, and there's 13 sweets that are lemon flavoured. So that means the rest of the sweets must be strawberry flavoured. So that means that if we do 50 take away 13, that'll tell us how many strawberry flavoured sweets are in the bag. So that's what I'm going to do to begin with. I'm going to do 50 subtract 13. So let's do that. So 0 take away 3, well, we're going to need to borrow. So that's now 4 and a 10. 10 take away 3 is equal to 7, and 4 take away 1 is equal to 3. So that means there's 37 strawberry sweets in the bag. Now we've been asked to find the probability that this sweet that's taken at random is strawberry flavoured. So that'd be 37/50ths, because 37 of the 50 sweets are strawberry. So that means that it's 37/50ths. And that's it. And that fraction can't be cancelled down. So that's our answer, 37/50ths. So let's just write that down, 37/50ths. Okay, let's have a look at our next question, question number 15. So question number 15 says, a teacher surveyed the 30 students in their class about how they travelled to school. And 5 of the students walked to school, 8 of the students cycled to school, 6 of the students travelled to school by bus, and the rest of the students in the class travelled to school by car. And we've been told a student is going to be picked at random from the class. So one of the 30 students is going to be picked at random. And the question says, find the probability that the student travelled to school by bus or by car. Now we know that 6 of them travelled to school by bus, but it'd be great if we knew how many students travel to school by car. So let's work out how many students travel to school by car. So we know there's 30 students in the class. If we add together 5, 8 and 6, so the number of students that walked, cycled and travelled to school by bus, then we can add them together and take that away from 30, and what's left would be how many travel to school by car. So let's work that out. So 5 plus 8 plus 6, well, that's going to be equal to 19, so that's 19. And then we're going to do 30, take away 19, and that's equal to 11. So it means that 11 students travel to school by car. Now we've been asked to find the probability that the student that's picked at random from the class travel to school by bus or by car. So let's work out how many students travelled to school by bus or by car. So 6 travelled by bus, 11 travelled by car. If we add them together, that'll tell us how many students travel to school by bus or by car. So that would be 17. 6 plus 11 is equal to 17. So that means that 17 students travel to school by bus or by car. So the probability that the student that's picked at random from the 30 students in the class travelled to school by bus or by car would be 17 30ths. So 17 out of the 30, 17 30ths. And that's it. And 17 30ths can't be cancelled down, so that's it. That's our answer, 17 30ths. And let's just write that in the answer box, 17 30ths. Okay, let's have a look at the next question, question number 16. So question number 16 says, Sean's got a box of pens and the box contains 6 blue pens, 8 black pens and 3 red pens. And he's going to pick a pen at random, and the question says, what's the probability that he picks a blue pen? Well, let's work out how many pens he's got altogether. 6 plus 8 plus 3. We're going to add together the number of blue, black and red pens and see how many are in the box altogether. So 6 plus 8 is equal to 14 plus 3, 17. So there's 17 pens in the box. And we want to find the probability that he picks a blue pen at random. So it's going to be, if we have a look, there's 6 blue pens, so it's going to be 6 17ths. 6 out of 17 pens are blue, and that's it. And that fraction can't be cancelled down, so that's our answer, 6 17ths. Okay, our next part, part B, says find the probability that he picks a green pen. Okay, so we know there's 17 pens again altogether, so it's going to be out of 17. And let's see how many green pens there are. So if we have a look, well, there's actually no green pens. So actually, I should have just read that. There's no green pens in the box. So the answer would be 0, or 0 out of 17, which is just 0. And that's it. So, okay. Okay, then if we carry on, we're then told that some more blue pens are added to the box. So let's just go and write down what we had. We had 6 blue pens, so there's 6 blue. There were 8 black, and there was 3 red. And we're told, so some more blue pens are added to the box, or some more blue pens are added to the box, and we're told the probability of selecting a blue pen now is a half. And part C says how many blue pens are added to the box. Okay, so some more blue pens are added to the box, and the probability of selecting a blue pen at random from the box now is a half. So that means that half of the pens will be blue, and half of the pens will be other colours. Now, only blue pens are added to the box, no other pens are added to the box. So if we add together the number of black pens and red pens, that'll tell us how many are not blue. So if we do 8 plus 3, 8 plus 3 is equal to 11. So in the box at the minute, there's 6 pens that are blue, and there's 11 pens that are not blue. Now, for there to be a probability of selecting a blue pen of a half, that means that there be an equal number of blue pens and not blue pens, because the probability of a half means you're as likely of selecting blue as not likely. So that even chance, remember? So that means there must be now 11 blue pens as well. So it must be that there's 11 blue and 11 not blue. So if there's 11 blue pens in the box, that means that 5 blue pens have been added to now give 11 blue pens. So the question is how many blue pens were added to the box? The answer would be 5. And let's just check that. If 5 blue pens were added to the box, there'd be 11 blue pens. Altogether then, if you do 11 plus 8 plus 3, that's equal to 22. And 11 of them are blue, so the probability of picking a blue pen would be 11 20-seconds. And then if you cancel that down by dividing both the numerator and denominator by 11, you get that's equal to 1/2. So that means that 5 blue pens were added to the box. And that's it. Okay, let's have a look at our next question, question number 17. So question number 17, part A says, list the prime numbers that are less than 20. So the prime numbers, well, they're 2, 3, 5, 7, 11, 13, 17, and 19. They're the prime numbers that are less than 20. Remember, prime number is a number that you can only divide by 1 on itself. It's only divisible by 1 on itself. So 2, you can only divide by 1 on 2. Its factors are only 1 on 2. 3, its factors are only 1 on 3. 5, its factors are only 1 on 5. 8's not prime, for instance, because its factors are 1 on 8, but also 2 and 4, so 8's not prime. So these are the prime numbers that are less than 20, and it's quite important you know your prime numbers. Okay, then if we carry on, we're told a prime number less than 20 is picked at random. So a prime number less than 20 is picked at random. So there's a prime number less than 20 that's going to be picked at random. So it's going to be one of these numbers. And part B says, write down the probability that the prime number is even. Well, 2's the only even prime number. That number is even, 2's even, and then all the rest of the prime numbers will be odd. 2's the only even prime number because all the other even numbers are divisible by 2, so 2 would be a factor of 4, 6, 8, and so on, so 2's the only even prime number. So one of these prime numbers less than 20 is picked at random, and we've been asked to write down the probability that the prime number is even. Well, there's one even prime number out of the 1, 2, 3, 4, 5, 6, 7, 8 prime numbers that are less than 20, so that would be 1 out of 8, or 1/8. So the probability that whenever you pick a prime number less than 20 at random, that prime number is even would be 1/8. And that's it. Okay, let's take our next question, question number 18. Question number 18 says that Tony makes a fair six-sided spinner. So he's made a fair six-sided spinner, and the spinner has got the numbers 7, 8 and 9 on it. So there's the numbers 7, 8 and 9. And we've been told the probability that the spinner lands on 7 is greater than the probability that it lands on 8. So there's going to be obviously more 7s on the spinner than 8s, because the probability it landed on 7 is greater than it landed on 8, and it's fair. So that means there's more 7s than 8 on the spinner. And the probability that the spinner lands on 9 is 1/3. And we've been asked to write down the numbers on the spinner. Okay, so we've been told that the probability that it lands on 9 is 1/3. So that means that 1/3 of the numbers on the spinner are 9. So if we count out, well, there's 1, 2, 3, 4, 5, 6 sections, and we were told it's a six-sided spinner, so it's got 6 sections. If we do 1/3 of 6, that'll tell us how many 9s are on the spinner. So 1/3 of 6, well, if we take 6 and divide it by 3, that's equal to 2. So that means there must be 2 9s on the spinner. So it must be a 9 and a 9. So let's just check that. If you've got a spinner with 6 sections, and 2 of the sections have got 9s on them, if you wanted to find the probability of getting a 9, it'll be 2 out of 6, so 2/6. And 2/6 can be cancelled down to 1/3, so that'll be right. So that means there must be 2 9s on the spinner. And also we just done 1/3 of 6, and that told us there's 2 9s on there. Okay, so we know there's 2 9s on the spinner. So the rest of the sections must have 7s or 8s in them. Now we're told the probability that the spinner lands on 7 is greater than it landed on an 8. So that means there's going to be more 7 than 8s. But there's 4 sections, so it's not going to be 2 7s and 2 8s. It's going to have to be 3 7s and 1 8. Because the probability of getting a 7 is greater than the probability of getting an 8. And we know that it does have 7s, 8s and 9s on it, so there has to be at least 1 8. So that's it. So we've filled out the numbers on the spinner. The probability of getting a 9 would be 2/6 or 1/3 if you cancel it down. And the probability that the spinner lands on 7 is greater than it landed on an 8. And that's it. Okay, let's look at our next question, question number 19. Question number 19 says the table below shows the number of coins in a bag. So there's 24 1p coins, 18 2p coins, 14 5p coins, and 12 10p coins. And Alicia takes a coin at random from the bag, and we've been asked to write down the probability that it's a 2p coin. So let's see how many coins are in the bag altogether. And it's a calculator question, so that's quite nice. We can just do 24 plus 18 plus 14 plus 12, and that's equal to 68. So there's 68 coins in the bag. And Alicia's going to take one of those coins at random, one of those 68 coins at random, and we want to find the probability that it's a 2p coin. There's 18 2p's in that bag. So the probability of getting a 2p coin would be 18 68ths, because 18 out of the 68 coins are 2p coins. And then we can cancel that down, and actually it's a calculator question, so if we just type in 18 68ths, that's equal to 9 34ths. And that's it. Actually, just half in both of those. Now, just remember, the question didn't ask us to cancel it down, so you could leave your answer as 18 68ths, but I would just cancel it down if you can. And that's it. Okay, so that's question number 19. So what's the probability of getting a 2p coin? 19 34ths. Okay, let's have a look at our next question, question number 20. So question number 20 says, Elizabeth has a bunch of red, yellow and white roses, and she chooses a rose at random. And the probability that she chooses a yellow rose is 0.1, and the probability that she chooses a white rose is 0.2. And part A says, what's the probability that Elizabeth chooses a rose that's either yellow or white? So if we want to find the probability that she chooses either a yellow rose or a white rose, we just need to add together those probabilities. So we just need to do 0.1 plus 0.2. Because if there's a 0.1 chance of getting a yellow rose and 0.2 chance of getting a white rose, if we add them together, that's equal to 0.3. And that would mean there's a 0.3 chance of getting either a yellow rose or a white rose. So the answer would be 0.3. And then if we have a look at part B says, what is the probability that Elizabeth chooses a red rose? So we know that the probability that Elizabeth chooses a white rose or yellow rose is 0.3, because 0.1 plus 0.2 is 0.3. Now, because it's just red, yellow and white roses in the bunch, that means that the probabilities will have to add together to be 1. So it means that all the rest of the roses will be red. So if we do 1 take away 0.3, that's going to be equal to 0.7. So 1 take away 0.3 will be equal to 0.7. And that's it. So the probability that Elizabeth chooses a red rose is 0.7. And we can check that. The probability that she chooses a red rose is 0.7, a yellow rose is 0.1, and a white rose is 0.2. And if you add those probabilities together, you get 1. And then if we carry on, part C says there were 10 roses in the bunch originally. How many roses were red? Well, if we take the probability of the rose being red, which is 0.7, and we multiply that by how many roses are in the bunch, which is 10, that'll tell us how many red roses there are in the bunch. So if you just times the probability by how many there are, that'll tell you how many of them will be red. So 0.7 times 10 is equal to 7. So that means there would be 7 red roses in the bunch. and that's it. And you can check that, because if there's 10 roses and 7 of them are red, the probability of choosing a red one would be 7/10, and you can change that to a decimal, which is 0.7, and that's it. Okay, let's look at our next question. So question number 21. Question number 21 says, as part of a game, Walter's going to pick a card at random from a deck. If the card that Walter picks has a star on it, he wins the game. And if he does not pick a card with a star on it, he will not win the game. So if he picks a card with a star on it, he wins. And if he picks a card that doesn't have a star on it, then he doesn't win. And we're told that there's 8 cards that have stars on it, and the rest do not. And we're told there's a total of 60 cards. And the question says, find the probability that Walter does not win the game. So in other words, we want to find out, because he's picking a card at random from this deck of 60 cards and he doesn't win the game, that means we're looking for a card that does not have a star on it. Because if he picks one with a star, he wins the game, and if he picks one without a star on it, then he doesn't win the game. So let's find out how many cards do not have stars on them. So the 60 cards altogether, and 8 of them have stars. So if we do 60, take away 8, that's equal to 52. So that means that 52 cards do not have a star on it. Now, if we want to find the probability that he doesn't win the game, we just need to find the probability that the card that he picks does not have a star on it. So that'll be 52 out of 60. So 52 60ths. So that's the probability that Walter does not win the game, 52 60ths. Now this can be cancelled down. We could half both of those to be 26 30ths. We could half them again to be 13 15ths. And that's it, so 13 15ths. So the probability that Walter does not win the game would be 13 15ths. Now, you don't have to cancel down the probability if you don't want to, because the question didn't say you had to cancel it down, but I would just tend to if I can, and that's it. Okay, let's have a look at the next question, question number 22. Okay, question number 22. Question number 22 says, Mia has 5 numbered cards, so she's got 5 numbered cards, and we know that one of them's got a 7 on it, and one of them's got a 5 on it, and then there's 3 other cards, and we don't know what those numbers are yet. And we're told one of the cards is chosen at random. And Mia says the probability of an odd number is 3/5. So that means if the probability of getting an odd number is 3/5, it means that 3 of the 5 cards will have to be odd. So here we've got an odd number, an odd number. It means there's one more odd number, and then we'd have 2 even numbers. Okay, let's carry on. The probability of a 7 is 2/5. So because there's 5 cards and the probability for 7 is 2/5, that means 2 of the cards have got a 7 on it. So there's one with a 7. Let's write another one with a 7. And actually now if we have a look at it, we've got an odd number, an odd number, and an odd number. So the probability of getting an odd number would be 3/5. So that means that these 2 numbers have to be even. Okay, let's carry on. And then we're told the range of the numbers is 10. So that means that the biggest number take away the smallest number is 10. And the probability of a 2 is equal to 0. Okay, so in terms of these cards, we know there's no 2s on them because we're told the probability of getting a 2 is 0, so that's impossible. So these have not got 2s on them. The range of the numbers is 10, so that's the biggest number, take away the smallest number. So if 5 was the smallest number, if you added 10 onto that would be 15. So 15 take away 5 would be equal to 10. But it can't be 15 because 15 is odd and we can't have another odd number. So these 2 numbers have both got to be even. And if the range is equal to 10, then I'm thinking that one of these is going to be the smallest and one of them is going to be the biggest. So we know that the probability of getting a 2 is equal to 0. So I'm going to choose 4. So I'm going to choose 4 as the smallest number because the question said fill in 3 numbers that could be on Mia's card. So 4 would work. And that means if 4 is the smallest, if we do 4 plus 10, that's equal to 14. So the range of these cards would be 10 because the biggest is 14. Take away the smallest is 4. And if you take them away, you get 10. So that's fantastic. So the range there is 10. And we've got the probability of getting an odd number is 3/5. Yep. We know the probability of getting a 7 is 2/5. Yep. And the probability of a 2 is 0. Yep. So there are 3 cards that could be on Mia's cards, a 7, a 4, and a 14, as well as the 5 and 7 she already had. Okay, let's look at our next question, question number 23. So question number 23, it's a calculator question, and we're told the counters are labelled A, B, C, D, and E, and they're placed in a bag. And the table shows the probability of picking each letter at random. So the probability of getting an A would be 0.07, the probability of getting a B would be 0.15, and so on. And we've been asked to calculate the missing probability in the table. So we want to find the probability of picking a D. Now we know that if the counters are labelled A, B, C, D, and E, these are all the letters. So that means that these probabilities would have to add together to be 1. So let's add together the probabilities that we know, these 4 probabilities, and then get that answer and take it away from 1. And that'll be the probability that we're missing, the probability for D. So 0.07 plus 0.15 plus 0.26 plus 0.18. And when we add those up, that's what we get, 0.66. So that means that the probability of getting an A, a B, a C, or an E would be equal to 0.66. So that means that if we want to find the probability for D, we're going to do 1 take away that probability. So 0.66. And 1 take away that answer is equal to 0.34. So that means the missing probability would be 0.34. And you can check that if you add those 5 probabilities up now, you should get that's equal to 1. Okay, let's have a look at part B. Part B says, what's the probability of a B or a C? So that means a B or a C. So we just need to add together those 2 probabilities, and that'll tell us the probability of getting a B or a C. So that'll be 0.15 plus 0.26, which is equal to 0.41. So the probability of getting a B or a C would be 0.41. And that's it. Okay, let's have a look at our next question, question number 24. So question number 24 says a bag contains 400 coloured counters, and the counters are either yellow, brown or green. And we're told there's 92 yellow counters in the bag, and we're told the probability that a brown counter is chosen at random from the bag is 0.13. And we've been asked to calculate the number of green counters in the bag. Okay, so what I'm going to do here is, well, we know that 92 of the counters are yellow, so I'm going to make a little table here, yellow, brown and green. And let's write down the number of each of those counters in the bag. So we know there's 92 yellow counters in the bag. Okay, now we were told the probability of a brown counter being picked at random from the bag is 0.13. So if we times that probability, 0.13, by how many counters are in the bag, which is 400, that'll tell us how many brown counters are in the bag. So if you times the probability by how many there are, that'll tell you how many brown counters there are in the bag. So 0.13 multiplied by 400 is equal to 52. So that means there's 52 brown counters in the bag. So that's fantastic. We now know how many yellow counters and how many brown counters are in the bag. To find how many green counters in the bag, we just need to add these 2 numbers together and take them away from 400. So 92 plus 52 is equal to 144. And then if we do 400 take away 144, that's equal to 256. So that means there's 256 green counters in the bag. And that's it. So I think the key part in this question is realizing that if you take the probability of a brown counter, which is 0.13, and you times that by how many counters are in the bag altogether, that'll tell you how many brown counters there are in the bag, which is 52. And then you can add the 92 yellow counters and the 52 brown counters together, take that away from 400, and that'll tell you how many green counters are in the bag, 256. Okay, let's look at our next question, question number 25. So question number 25 says, Emily has a spinner that has got 5 equal sections. So as you can see, it's got 5 equal sections. And she's got an ordinary fair 6-sided dice. So she's got this ordinary 6-sided dice. And then we're told that Emily says that the spinner is more likely than the dice to land on a number less than 5. Is Emily correct? Explain your answer. So let's find for the spinner the probability of a number less than 5, or probability of less than 5. And let's do the same for the dice. So let's find the probability of less than 5 on both the spinner and the dice. So in terms of the spinner, so with the spinner, the probability of getting a number less than 5, well, there's 1, 2, 3, 4, 5 sections in the spinner, and less than 5 would be 1, 2, 3 of them. So the probability of getting less than 5 for the spinner would be 3/5. For the dice, well, there's 6 numbers on the dice, 1, 2, 3, 4, 5, 6. And the probability less than 5, well, that'll be, there's 4 numbers less than 5 on the dice, that'll be, for the dice, that'll be equal to 4/6, because 4 of them out of the 6 are less than 5, so that'll be 4/6. So the probability of getting less than a 5 on the dice would be 4/6, and that can be cancelled down to 2/3. So that's fantastic. We'll find the probability of getting less than a 5 on the spinner and less than a 5 on the dice. Now, she said it's more likely to get a number less than 5 on the spinner than the dice. We just need to compare these 2 probabilities and see which one's bigger. And which one's bigger is the one that's most likely to land on a number less than 5 on. So let's have a look at these. So we've got 3/5, and 3/5 is equal to 0.6 as a decimal number. And we've got 2/3, and that's equal to 0.6666, and so on. So remember, that's a recurring decimal, 0.666, and so on. So that means that 2/3 is bigger than 3/5. So that means that because 2/3 is bigger than 3/5, this probability is bigger than this probability. So it means it's more likely to land on a number less than 5 on the dice than on the spinner. So is Emily correct? No, she's got it the wrong way around. So let's explain that. And that's it. I've just explained that no, the probability of getting a number less than 5 on the dice is 2/3, which is 0.6666, and so on. And on the spinner is 3/5, which is 0.6. And that means that 2/3 is bigger than 3/5. So it means it's more likely to get a number less than 5 on the dice than on the spinner. And that's it. So Emily's incorrect. Okay, let's have a look at our next question, question number 26. So question number 26 says, the table shows the ages of all the members of a running club. So we've got the ages here and the number of members in each of these groups, each of these age categories. So here, for instance, we've got that the ages are bigger than or equal to 60 years old, but less than 70 years old. And there's 19 members in that category. And part A says, find the total number of members of the running club. So we want to find the total number of members of the running club. So we just need to add together these frequencies, the number of members. So if we add those up, let's see what we get. And it's great, it's a calculator question, so we can just add these on our calculator. And that's equal to 170. So there's 170 members of the running club. And then part B says, the running club has been awarded one place for the London Marathon, and a member of the running club is going to be chosen at random to receive this place. So one of these members, one of these 170 members, is going to be lucky enough to receive a place for the London Marathon. And part B says, find the probability that the member chosen is less than 40 years old. So let's find out how many of the members are less than 40 years old. So less than 40 years old, well, that would be this category here. All the members in this age category are less than 40 years old. But also here, the age is bigger than or equal to 30, but less than 40. So these members would also be less than 40 years old. So that means if we add together 27 and 45, that'll tell us how many members are less than 40 years old. So 27 plus 45 is equal to 72. So that means there's 72 members that are less than 40 years old in this running club. So that means if one of them is picked at random, one of the 170 members is picked at random, there's going to be 72 possible members that are less than 40. So that means the probability of picking someone that's less than 40 would be 72 over 170. And that's the probability that the member chosen is less than 40 years old. Now we can cancel it down, we're not asked to, but we can if we wanted to. If we cancel that down, we're going to get that's equal to 36/85. And it's a calculator question, so I just type that into my calculator and press equals and it cancels it down for me. Or we could just have the numerator and the denominator. We get that as well. And that's it. Okay, let's have a look at our next question. So question number 27 says that Shuna's got 9 red pens, 4 blue pens and 7 green pens. And she buys 12 more pens, and the pens she buys are either blue or green. So she doesn't buy any more red pens, but she buys blue or green pens. Shuna puts all the pens together and picks one of them at random. So she's going to put all the pens together and pick one at random, and the probability that she picks a green pen is a half. And the question says, how many green pens did she buy? Okay, so to start off with in this question, I want to find out how many pens she's got to begin with. So she's got 9 red, 4 blue and 7 green. Let's add those up. 9 plus 4 plus 7 is equal to 20. So she had 20 pens to begin with. And then she bought 12 more pens. So she bought 12 more pens. So if we have 20 and we add another 12, altogether that would be 32. So that means that Shuna's got 32 pens. Now, we're told that the probability that she picks a green pen is a half. So that means that after she buys her pens, that half of them are green. So if we do half of 32, that'll tell us how many green pens it would be. And a half of 32 is equal to 16. So that means there's 16 green pens. Now that's after she bought the 12 extra pens. The question said how many green pens did she buy? So she had 7 to begin with, and then she ended up with 16. So if we do 16 take away 7, that's equal to 9. So that means she must have bought 9 green pens. So she bought 9 green pens. And altogether she bought 12 pens, so there's 12 pens, and if 9 of them are green, that means the rest of the 3 other ones would be blue. Not that we need to work this bit out. So she bought 9 green pens and 3 blue pens. But the question is, how many green pens did she buy? The answer is 9. So just to recap, we added up how many pens she had to begin with, which was 20. She bought 12 more, so that means she has 32 pens. The probability of picking a green pen is a half. That means that half of the pens are green, so that means there's 16 green pens. And we took away the 7 that she had to begin with, so that meant she bought 9 more. So the answer is 9. Okay, let's have a look at our next question. Question number 28 says, each boy at a school plays one of 4 sports, and the table shows the probability that a student chosen at random plays rugby, football, hockey or cricket. And we're told the student is chosen at random, and part A says work out the probability that the student plays cricket. So we want to find this missing probability. Now we're told they play one of 4 sports. That means that these 4 probabilities will have to add together to be 1. So 0.4 plus 0.2 plus 0.1 is equal to 0.7. And then if we do 1 take away 0.7, that's equal to 0.3. So this would have to be 0.3 so that these probabilities add together to be 1. So the probability of playing cricket would be 0.3. Okay, and then if we go on down, we're told there's 600 boys at the school, and part B says work out the number of boys that play rugby. So if we times the probability that they play rugby, which is 0.4, and we multiply that by the number of boys that are all together, that'll tell us how many will play rugby. So if we do the 0.4 times 600, that'll tell us how many play rugby. And this is a calculator question, so we just type that into our calculator, and when we do 0.4 times 600, that's equal to 240. So that means that 240 boys play rugby. And that's it. Okay, let's have a look at our next question, question number 29. So question number 29 says, a game is played with a 5-sided spinner and each section has a different colour and the spinner is biased. And then we've got this table and we've got the colours and some of the probabilities. And we're told the probability for green is equal to the probability for pink. We've been asked to calculate the probability that the spinner lands on a pink. So we know that these two probabilities are the same as each other. So that means that if we add together the probabilities we've been given, so the 0.3, the 0.1 and the 0.12, that tells the probability of the spinner landing on red, blue or black. If we take that away from 1, we'll know what's left for these two colours, green and pink, and then if we half it, we'll find the probability of each of them. So let's do that. So let's add together the probabilities, 0.34 plus 0.1 plus 0.12, and that's equal to 0.56. And then let's take this away from 1. So 1 take away 0.56 is equal to 0.44. So that means the probability that the spinner lands on green or pink is 0.44. If we now half that, so 0.44 divided by 2, that's equal to 0.22. So that means that this probability must be 0.22, and this probability, the one we're looking for, must also be equal to 0.22. So 0.22, and that's it. Okay, let's look at our next question, question number 30. So question number 30 says, a hockey club brought 2 coaches of supporters to a match, and the first coach has 24 supporters on board, and the second coach has got 36 supporters on board. The probability of the supporter on the first bus having a flag is equal to a quarter, so a quarter of these supporters have flags, and the probability that a supporter on the second bus has a flag is equal to 2/9, so 2/9 of these supporters have flags, and we've been asked to work out how many supporters on the 2 buses have flags. Okay, so we're told the probability that a supporter selected at random on bus 1 having a flag is equal to a quarter. That means that a quarter of these supporters, so a quarter of 24, will have flags, and a quarter of 24 is equal to 6. So that means that 6 supporters in this bus have flags. Now, in terms of the second bus, we're told the probability that they have a flag is equal to 2/9. So that means that 2/9 of those supporters, 2/9 of 36, will have flags. And to find 2/9 of a number, we divide by the bottom and times by the top. So 36 divided by 9 is equal to 4, times 2 is equal to 8. So that means that there's 6 supporters on this bus that have flags, and there's 8 supporters in that bus that have got flags. And the question says, how many supporters on the 2 buses have a flag? Well, it'll be 6 plus 8 is equal to 14. So it means that 14 supporters have a flag. And that's it. Okay, let's take our next question, question number 31. So question number 31 says, Dennis has got a bag of counters, and the counters are red, green, white or pink. So red, green, white or pink. And we're told there's 200 counters in the bag. So there's 200 counters altogether in the bag. So that's quite an important number. And we're told the probability for pink counter is 0.15. So the probability for pink counter is 0.15. And the probability for green counter is 0.25. So 0.25. And then we're told the probability of a red counter is twice the probability of a white counter. So this probability is twice this probability, because it's twice as likely to pick a red counter than a white one. So let's actually find those two probabilities, because if we add together these two probabilities, the probability for green or pink, that'll tell us the probability of it landing on green or pink. And then we'll know that if we take that away from 1, what's left for the other two probabilities. So 0.25 plus 0.15 is equal to 0.4. So that means that these two probabilities add together to be 0.4. Now let's take that away from 1 to see what's left for the other two colours. So 1 take away 0.4 is equal to 0.6. So that means that this probability and this probability would add together to be 0.6. Now, they're not equal. It's not going to be 0.3 and 0.3 because we're told that this probability is twice that probability. Well, actually, I can spot it straight away. That's going to be 0.4 and that's going to be 0.2 because 0.4 is double 0.2 and they both add together to be 0.6. So I just spotted it there. Another way to do it would be to actually use algebra and call this 2x and this x. And then you could do 2x plus x is equal to 3x's. And then you do 3x equals 0.6, the probability that they add together to be. Divide both of them by 3 to get that x is equal to 0.2. And that means that this would be 0.2 and this would be 0.4, double it. But in this case, I just spotted it. Okay, that's fantastic. So we now know the probabilities. Now the question asks us for the number of red counters in the bag. So we want to find out how many red counters in the bag. So the probability of getting a red counter is 0.4. And if we times that by the number of counters in the bag, 200, that'll tell us how many red counters there'd be. And 0.4 times 200 is equal to 80. So it means there's going to be 80 red counters in the bag. And that's it. Okay, let's look at the next question, question number 32. Okay, question number 32. So question number 32, we've got this table and it says a rugby team can win, draw or lose a match, and the table shows the probabilities of each result. So the probability that the rugby team win the match is equal to 0.4, lose the match is 0.35, and we've got this missing probability here for lose. And part A says calculate the missing probability in the table. So we want to find this probability, so the probability of the team losing a match. Now these probabilities will have to add together to be 1 because the team can either win, draw or lose the match. Nothing else can happen. So if we do 0.4 plus 0.35, that's equal to 0.75. So that means the probability that the team win or draw is equal to 0.75. Then if we take that away from 1, we can find the probability of the team losing. So 1 take away 0.75 is equal to 0.25. So that means the probability that the team lose the match would be 0.25. That's the missing probability, 0.25. Okay, and then if we go on down, part B. Part B says that each win is worth 2 points, each draw is worth 1 point, and each loss is worth 0 points. The rugby team played 20 games in a season, and we've been asked to work out how many points the rugby team should receive in one season. Okay, so let's work out how many points they should receive in a season. So let's find out how many matches they should win. So they play 20 matches, and if we go up win, the probability of winning a match is 0.4. So if we do 0.4 multiplied by 20, the number of matches they play, that tells how many matches they should win. And 0.4 times 20 would be equal to 8. So that means they should have 8 wins. Okay, so that's fantastic. We know how many wins they should have. Now let's work out how many draws they should have. The probability for draw is 0.35. If you times that by 20, you get that's equal to 7. So there should be 7 draws. And we know that the probability for losing is 0.25. If we times that by 20, that's equal to 5. So there should be 5 losses. So that means that the rugby team should win 8 times, draw 7 times, and lose 5 times. That's fantastic. And let's just check. 8 plus 7 is 15, plus 5 is 20. Great. Now let's work out how many points they should get. So each win is worth 2 points. So 8 times 2 is equal to 16. So they should get 16 points for their wins. Okay, now let's consider the draws. Each draw is worth 1 point. So 7 times 1 is equal to 7. So they should get 7 points for their draws. And then in terms of the losses, well, each of the losses is worth no point, so we don't even need to consider those. Okay, so to work out how many points the team should receive in a season, we just need to add together the 16 and 7. And 16 plus 7 is 23. So that means the rugby team should receive 23 points in a season. 23 points. And that's it, 23. Okay, let's look at our next question. So question number 33 says, Susan's got some beads in a bag, and 5 of the beads are orange, 3 of the beads are purple, and the rest of them are pink. And we're told that Susan takes a bead from the bag at random, and the probability that she picks a pink bead is 3/5. And the question says, work out how many pink beads are in the bag before Susan takes the bead. So how many pink beads are originally in the bag? Okay, so let's have a look at this question. So first of all, we're told in the bag there's orange beads, and there's 5 orange beads, and there's purple beads, and there's 3 of those, so there's 3 purple beads, and there's pink beads, but we don't actually know how many pink beads there are, but that's what we're trying to find out. Okay, now we know the probability that she takes a pink bead would be equal to 3/5. Now I'm going to take that away from 1. I'm going to do 1 minus 3/5. And if we do 1 minus 3/5, well, 1 is 5/5, and if we take away 3 of the fifths, we're left with 2/5. And that makes sense because 3/5 plus 2/5 is equal to 5/5, or 1. So I've taken 3/5 away from 1 because that tells us the probability of getting not a pink. So that's the probability of not pink. Or in this case, not pink would be the probability of getting either an orange or purple because they're the only other options. So the probability of a pink is equal to 3/5, and the probability of not pink would be these 2 options here. So that's equal to 2/5. So that's fantastic. We now know the probability of getting a not pink is equal to 2/5. So that means the probability of getting an orange or purple is equal to 2/5. And if I wanted to write down the probability of getting an orange or purple, what I would do is I would say it's 8 over the grand total. For instance, if I know there was 50 beads, I would put 8 over 50 or whatever. But here, if we do 8 over the grand total, would have to be equal to 2/5. If you cancel it down, we're going to get that's equal to 2/5 because 8 out of the grand total is equal to 2/5. So that's great. We can now find the total number of beads because obviously 8 has been divided by 4 to get that's equal to 2. So that means that the total number of beads would have to be, if we do 5 times 4, 5 times 4 is equal to 20. This number here has to be 20 because it has to be divided by 4 as well. So that means there has to be a total of 20 beads in the bag. So there had to be a total of 20 beads in the bag. And if 8 of them are orange or purple, the rest of them, well, 5 plus 3 is equal to 8. So that means the rest would have to be 12. So that means there has to be 12 pink beads in the bag, 12. And that's our answer, 12. And we can check our answer. 12 over 20. If we cancel down 12 20ths, 12 20ths, if you divide both the numerator and denominator by 4, you get that's equal to 3/5, which we were told in the question. So that means it would have to be 12 pink beads in the bag. Okay, let's look at our next question, question number 34. So question number 34 says the probability of James winning a competition is 0.03. So it's quite a low probability that he wins the competition, 0.03 or 3%. And the question says what's the probability that James does not win the competition? So the probability of him winning and the probability that he not wins the competition will have to add together to be 1. So if we just take this probability away from 1, we just do 1, take away 0.03, and that's equal to, it's a calculator question, but I can just do that in my head, 0.97. So the probability that he does not win the competition will have to be 0.97. And that's it. We just take the probability that he wins the competition away from 1, and what's left to be the probability that he doesn't win the competition. Okay, let's look at our next question, question number 35. So question number 35 says that Beatrice flips a biased coin, and the probability that that coin lands on heads is 3/20. And we're asked to write down the probability that the coin lands on tails. So again, the probability that it lands on heads and the probability that it lands on tails will add together to be 1. So we could just do 1 take away 3/20, and 1 take away 3/20. Well, it's a calculator question, you just type that into your calculator, or just consider that 1 is 20/20, and 20/20 take away 3/20 would be 17/20. Or you could just think, if I've got 3/20, what do I need to add to that to get 1? The answer would be 17/20. So that's it. The probability that the coin lands on tails would be 17/20. So you just do 1 minus the probability that it lands on heads. Okay, let's look at the next question, question number 36. Question number 36 says, Mrs. Jenkins is organising a charity raffle, and she sells 300 tickets at £3 each. And the probability that someone wins a prize is equal to 0.2. And we're told that each prize costs £8, and the profit is donated to charity. Work out how much money Mrs. Jenkins should donate to charity. Okay, so let's work this out. So there's 300 tickets sold at £3 each. So let's work how much money she receives. So 300 multiplied by £3 is equal to £900. So that means that she receives £900 in total for the tickets that she sells. Okay, now let's consider that's the total amount of money she has, but obviously there's some prizes and we need to work out the cost of those prizes. So we're told that the probability that someone wins a prize is equal to 0.2. So if we do the probability of someone winning a prize, which is 0.2, by the number of tickets sold, which is 300, if we do 0.2 times 300, that means that that's going to be equal to 60. So that means there's going to be 60 prizes. And each prize costs £8. So if we do 60 times £8, that'll tell us the price of those prizes. And 60 times 8 is equal to £480. So it means the prizes cost a grand total of £480. Now we're told the profits donated to charity. Well, she's received £900, but £480 has to go out for the cost of the prizes. So 900 take away 480 will be what's left, the profit, which is equal to £420. So that means that Mrs. Jenkins should donate £420 to charity, and that's it. Okay, let's look at our next question, question number 37. So question number 37 says, over the course of a day, 200 adults and 70 children visit a library. And if an adult is picked at random, the probability that they have a library card is 0.87. And if a child is picked at random, the probability that they have a library card is 0.4. And then we're asked to find how many people visited the library without a library card. Okay, so let's start off with the adults. If we take the probability that they have a library card, which is 0.87, and we multiply that by the number of adults, which is 200, that'll tell us how many adults have library cards. So 200 multiplied by 0.87 is equal to 174. That means there's 174 adults with a card, 174 adults with a library card. So if we take that away from 200, if we do 200, subtract 174, that's equal to 26. So that means there's 26 adults without a card. So that's fantastic. We've now worked out how many adults went to the library without a library card. There was another way to do that. You could have taken the 0.87 away from 1, which is 0.13, and do 0.13 times 200, and that's equal to 26 as well. Okay, so that's the adults. Now let's deal with the children. So we'll take the probability that they have a library card, which is 0.4, and times that by 70, because there's 70 children, and that's equal to 28. So that means that 28 children had a library card. And if we want to work out how many children did not have a library card, we'll take the 28 away from 70. So 70 take away 28 is equal to 42. So that means there's 42 children without a library card. And just to mention, we could have here done 1 take away 0.4, which is 0.6. That's the probability that a child does not have a library card, and times it by 70 and got 42 straight away. So that's fantastic. We now have worked out how many adults did not have a library card and how many children did not have a library card. To find the total number of people, we just add them together. So 26 plus 42 is equal to 68. So the 68 people went to the library without a library card. And that's it. Okay, let's have a look at our next question. So question number 38 says, below is a biased four-sided spinner, and it's got four sections, 1, 2, 3, and 4. And the probability of it landing on a 2 is 0. The probability of landing on a 4 is 0.15, and the probability of a 1 is double the probability of a 3. And we're told the spinner is spun 500 times, and the question says calculate the number of times you'd expect it to land on a number 3. Okay, so let's first of all find, if we know the probability of it landing on a 2, the probability of a 2 is equal to 0.25, and the probability for 4 is equal to 0.15. If we add those two probabilities together, so 0.25 plus 0.15, that's equal to 0.4. So that means the probability for 1 and a 3, these two probabilities have to add together to be 0.6, because the spinner has to land on one of these four numbers. So if we do 1 take away 0.4, that's equal to 0.6. Now we're told the probability that it lands on a 1, so the probability for 1 is double the probability that it lands on a 3. Now these two numbers will have to add together to be 0.6. Now again, I can spot that straight away. This is going to have to be 0.4 and this is going to be 0.2, because the probability for 1 is double the probability of a 3, but also the fact that these two numbers add together to be 0.6. Now, one way we could have done it was, if rather than spawn it and noticing it was 0.2 and 0.4, we could let the probability if it landed on a 3 be equal to x. That means the probability if it landed on a 1 would be equal to 2x, because it's double the probability of it landing on a 3. And then we can make an equation, because we know that 2x plus x has to be equal to 0.6. So 2x plus x is equal to 3x. That's equal to 0.6. And then if we divide both sides of the equation by 3, we get that x is equal to 0.2. So that means that x is 0.2. So that means the probability of it landing on a 3 would be equal to 0.2, and the probability if it lands on a 1 would be double that, which would be 0.4. Now the question says it's spun 500 times, and it says calculate an estimate of the number of times we'd expect it to land on a 3. So the probability of a 3 is equal to 0.2. It's spun 500 times, so if you multiply the probability of a 3 by the number of times it's spun, that'll tell you how many times you would expect it to land on a 3. Now it may not, it may be slightly different, but it should be roughly equal to this. So 0.2 times 500 is equal to 100. You'd expect it to land on a 3 100 times, and that's it. Okay, let's have a look at our next question, question number 39. So question number 39 says, Richard has got 2 bowls of fruit, and bowl A contains 8 lemons and 6 limes, and bowl B contains some lemons, 13 kiwis, and 15 limes. And then we're told, if a piece of fruit is chosen from each bowl, the probability of choosing a lime from bowl A is the same as the probability of choosing a lime from bowl B. And the question says, work out how many lemons are in bowl B, because obviously we don't know how many lemons are in bowl B, we've just told us some lemons there. Okay, so let's have a look at bowl A to begin with, because we know the probability of choosing a lime from bowl A is the same as the probability of choosing a lime from bowl B. So let's focus on bowl A to begin with, and let's find the probability of choosing a lime. Well, altogether there's 14 pieces of fruit, so it's going to be over 14, and there's 6 limes, so that's 6/14, and we can cancel that down to be 3/7. So the probability of choosing a lime from bowl A is equal to 3/7. Now we're told that probability is the same as choosing a lime from bowl B. So in terms of bowl B, the probabilities for bowl B, the probability of a lime is also going to be equal to 3/7. So that's going to be useful, because that'll help us find how many lemons are in the bowl. So if we have a look at this, bowl B, if I wanted to find the probability of choosing a lime from bowl B, I know it would be 15 over the number of pieces of fruit in the bowl. It would be 15 over something. That would be the total number of pieces of fruit. But we know that when this is cancelled down, we get an answer of 3/7, because we know the probability of choosing a lime is equal to 3/7. So that'll be equal to 3/7. So this is fantastic, because we can find this missing number now. To get from 3 to 15, we times by 5. So to get this denominator, we're going to do 7 times 5, and that's equal to 35. So that means the denominator would be 35. So that means there's 35 pieces of fruit in bowl B. That means now we can work out the number of lemons, because if we do 13 plus 15, 13 plus 15, that's equal to 28. And then if we do 35, the number of pieces of fruit take away 28, that's equal to 7. So that means there must be 7 lemons. And we could check that. If you were to add these together, you would get this 35 pieces of fruit. The probability of a lime would be 15/35, and then if you cancel that down, you get 3/7 again. So that's it, that's our answer. 7, there must be 7 lemons in bowl B, so the answer is 7. Okay, let's have a look at our next question, question number 40. So question number 40 says a spinner has got 3 sections. We've got yellow, purple and blue. And we're told the table shows some information about the probability of the spinner landing on each colour. So the probability of a yellow is equal to 5x plus 0.06. The probability of a blue is 0.1. And the probability of a purple is 2x. And the question says work out the probability of the spinner landing on yellow. So we want to find this probability. Now, because the spinner must land on either yellow, purple or blue, these probabilities will add together to be 1. If we add these probabilities together, we get 1. So that means we can form an equation. Let's add the x's to begin with. 5x plus 2x, that's 7x. And then we've got 0.06 plus 0.1, that is going to be plus 0.16. Just adding these probabilities together. And that's going to equal 1. Now we can solve this equation. We can find out what x is, and then once we find out what x is, we can substitute it in here and find the probability of a yellow. So let's solve this equation. We've got 7x plus 0.16 equals 1. So let's take away 0.16 from both sides of the equation. So that if we do that on the left-hand side, we'll be left with 7x. And on the right-hand side, we've got 1. Take away 0.16 would be 0.84. Now we want to find out what x is, so we're going to divide both sides of the equation by 7. We're going to divide by 7 and divide by 7. So on the left-hand side, we'll be left with x. On the right-hand side, we've got 0.84. We're going to divide that by 7, and let's see what we get. How many 7's going to 0? 0. How many 7's going to 8? That's 1, remainder 1. And how many 7's going to 14? That's 2. So that means that x is equal to 0.12. So that's fantastic. We've now found what x is. We can now find the probability if it landed on yellow, because that's 5x plus 0.04. So 5 times 0.12, it's a calculator question, so we can just type this into our calculator. We can just do on a calculator 5 times 0.12 plus 0.06. And when we do that, we get an answer of 0.66. So that means the probability if it landed on yellow would be 0.66. Just timesing that by 5, the 0.12 by 5, and adding 0.06. So that means the answer is 0.66, and that's it. Okay, let's have a look at our next question, question number 41. So question number 41 says, Finn has got 3 flavours of sweet in a box, lemon, strawberry and mint. And we're told 60 of the sweets are mint flavoured, so 60 sweets are mint flavoured. And we're told if a sweet is chosen at random from the box, the probability that the sweet is mint flavoured is 1/4. The probability that the sweet is strawberry flavoured is 7/12. And we've been asked to work out how many lemon flavoured sweets there are in the box. Okay, so first of all, we're not told how many sweets there are in the box to begin with. But we are told there's 60 sweets that are mint flavoured. But we're also told the probability of choosing a sweet that is mint is 1/4. So it means that 1/4 of the sweets are mint. And if there's 60 in the box, if we do 60 times 4, that'll tell us how many sweets are in the box altogether. So 60 times 4 is equal to 240. So there's going to be 240 sweets in the box. And let's just check that, because we know the probability of choosing a mint sweet is 1/4. That means that 1/4 of the sweets are mint, and 1/4 of 240 would be 60, and that's what we're told. So we just worked backwards there. So we just times the number of sweets that were mint by 4, and we got that's equal to 240. So there's 240 sweets in the box altogether. We know that 60 of them are mint flavoured. Now we're told the probability of choosing a strawberry sweet is 7/12. So that means that 7/12 of the sweets are strawberry flavoured. So we need to work out 7/12 of 240, because there's 240 sweets altogether. So let's work out 7/12 of 240. So let's take 240 and let's divide it by the bottom and times by the top. So if we do 240 divided by 12, that's equal to 20. And then if we times that by 7, 20 times 7 is equal to 140. So that means there's 140 strawberry sweets in the box. So we just worked out 7/12 of 240, and that's equal to 140. So that means there's 140 strawberry sweets. So that's fantastic. We now know there's 60 mint sweets, there's 140 strawberry sweets, and we want to work out how many lemon flavoured sweets there are. So we just need to add these together. 140 plus 60 is equal to 200, and then 240 take away 200 is equal to 40. So that means there's 40 lemon sweets in the box. That's it. So the answer is 40, and that's it. Okay, let's have a look at our next question, question number 42. So question number 42 says, Jack and Hannah both have some red cards and some black cards. So they've both got some red cards and some black cards. Jack has a total of 96 cards. So he's got 96 cards altogether. And for every 1 red card that he has, Jack has got 5 black cards. So for every 1 red card, he's got 5 black cards. So that means he could have 1 red and 5 blacks. He could have 2 reds and 10 blacks and so on. But we do know he's got 96 altogether, so we can work out how many red and how many black he has. We're told that Hannah's got a total of 40 cards, and she has twice as many red cards than Jack. So how many red cards Jack has, Hannah's got twice as many. And we're told that Jack and Hannah put all their cards on an empty table, so they're going to put all their cards on an empty table, and one of the cards is picked at random. And the question is find the probability that the card is black. So what we're going to do here is we're going to actually find out how many red and black cards each of them has. Because if we know how many cards they've got, how many red cards and how many black cards each of them has, when they put them all on the table, we'll know the total number of red and the total number of black cards. And that means we can then find the probability of it being black whenever one's picked at random. Okay, so let's start off with Jack. Jack has got 96 cards, and we know that for every one red card, he's got 5 black cards. So the ratio of red to black, the ratio of red cards to black cards would be 1 to 5. For every one red card, he's got 5 blacks. So that means that if we share 96 in the ratio 1 to 5, we can find out how many red cards and how many black cards he's got. So to share 96 in the ratio 1 to 5, we're going to add together the numbers in the ratio. 1 part plus 5 part is equal to 6 parts altogether. And then we're going to divide the total, 96, by that answer, by 6, because there's 6 parts in total. And if we do 96 divided by 6, that's equal to 16. So that means there's 16 in one part, so in one part. So that's fantastic. We now know there's 16 cards in one part. We're now going to times it by the parts in the ratio. We're going to do 16 times 1 and 16 times 5. So 16 times 1 is equal to 16. So he's got 16 red cards. And we're going to do 16 times 5, because that's the black number in the ratio, and 16 times 5 is equal to 80. So he's got 80 black cards. And what's fantastic is we can check that, because we know for every one red card, he's got 5 black cards. So if we do 16 times 5, we get that's equal to 80. So that's right. For every single red card, he has 5 black cards. Okay, so we now know for Jack how many red and black cards he's got. I'm just going to write Jack there, so just so we know that that's him. Now for Hannah. Hannah's got 40 cards. So Hannah's got 40 cards. And we know she's got twice as many red cards than Jack. So Jack has got 16 red cards. So if we do 16 times 2, that's equal to 32. So that means that Hannah has got 32 red cards. And we know she's got a total of 40 cards. So if we do 40, take away 32, that's equal to 8 black cards. So that means that Hannah has got 32 red cards and 8 black cards. And let's just check that. That is double the number of red cards, and they add together to be 40. So this is fantastic. We now know how many red cards each of them has and how many black cards each of them has. And we also know the totals, that Hannah's got 40 and Jack has got 96 altogether. Now we're told then that all those cards are placed on an empty table, and one of them is picked at random, and we want to find the probability of a black. So let's find out how many cards are all together. So that'll be 40 plus 96. That's equal to 136. So there's 136 cards altogether. And let's work out how many black cards there are. So we're going to do 8 plus 80. And 8 plus 80 is equal to 88. So there's 88 black cards. So if we want to find the probability of a black card being chosen, that's going to be 88 out of 136. So that's 88, 136. So that's the probability of a black card. That's fantastic. Now the question didn't say we needed to cancel it down, but I'm going to cancel it down anyway. I'm just going to get my calculator. I'm going to type in 88 over 136, and that's equal to 11/17. So the probability of a black card being chosen is 11/17, and that's it. Okay, let's have a look at our next question, question number 43. So question number 43 says a drawer contains black and white socks. So there's black socks and white socks in a drawer. And n of the socks are black. So n of them are black. We don't know how many. It could be 1, it could be 50, it could be 1,000. And the other 12 socks are white. So we know there's 12 white socks. Toby's going to choose a sock at random from the drawer. So he's going to pick one of the socks at random. And the question says write an expression in terms of n for the probability that Toby will take a white sock. So we want to find the probability of a white. Now the probability of picking a white sock will be the number of white socks over the total, and that'll be the probability of picking a white sock. So in terms of the total, there's n black socks and 12 white socks. So that means the total will be equal to, that's going to be equal to n plus 12, the number of black socks plus 12. So that means our denominator will be n plus 12, because we know altogether there's n plus 12 socks. Now, in terms of choosing a white, well, that'll be the number of white socks on the numerator, so that's going to be 12. So that means the probability of picking a white sock will be 12 over n plus 12, because that's 12 white socks over the total, which is n plus 12. And that's it. That's our expression in terms of n. The Toby will pick a white sock. It'll be 12 over n plus 12. And that's it. Okay, let's have a look at the next question, question number 44. Okay, question number 44, it says a box contains red pens, black pens and green pens. And we're told there's 3 times as many red pens as black pens in the box. And we're also told there's twice as many green pens and red pens in the box. And we're told that the teacher picks a pen at random from the box, and we've been asked to work out the probability that the teacher picks a red pen. Okay, now we don't actually know how many red pens and black pens and green pens there are, but we're told some information here. And what I'm going to do is I'm going to let one of them be equal to x, perhaps the one with the lowest number, and then what we're going to do is then find out expressions for the other ones, and then that might help us. So we're told there's 3 times as many red pens and black pens, and we're also told there's twice as many green pens and red pens. So in terms of the lowest one, I'm thinking that might be the black pens, because we know there's 3 times as many red pens than black pens, and there's twice as many green pens than red pens. That means that the lowest number probably will be the number of black pens. So I'm going to let the number of black pens be x. So that's our expression for the number of black pens, x. It could be 1, it could be 50, it could be 1,000,000, quite a big box. Now we're told there's 3 times as many red pens than black pens, so there's 3 times as many red pens. So we're going to times x by 3, so that'll be 3x. So that means the number of red pens will be 3x. Okay, so that's fantastic. We've got expressions for the number of black pens and red pens. Now let's have a look at the green pens. We're told there's twice as many green pens than red pens. So we know there's 3x red pens, and there's twice as many green pens, so that'll be 6x, it'll be double that. So that means the number of green pens equals 6x. So that's fantastic. We've now got expressions for the number of black pens, red pens, and green pens. We can use that to help us answer the question, to work out the probability that the teacher is going to pick a red pen. So in terms of the probability of a red pen being chosen at random, that'll be the number of red pens, which is equal to 3x, so that's the number of red pens, over the total. And the total number of pens, if we add those all up, x plus 3x plus 6x, that's going to be 10x. So that means there's 10x pens in the box. So that means that the probability of choosing a red pen will be 3x over 10x, because that's the number of red pens over the total. Now that can be cancelled down. We can divide both the numerator and denominator by x here, and that'll be equal to 3/10. So that means the probability of a red pen will be equal to 3/10, and that's it. Okay, and let's have a look at our last question, question number 45. So question number 45 says, Norman has a bag that contains 2p and 5p coins, and the ratio of 2p to 5p coins in the bag is 7 to 3. So for every 7 2p's, he's got 3 5p's. And we're told that 2 more 2p coins and 8 more 5p coins are added to the bag. And a coin's going to be picked at random from the bag, and the probability that this coin is a 5p is 2/5. Find out how much money was originally in the bag. So there's a lot of information here. We've got information about ratios, we're told some coins are added to the bag, we've got probabilities as well. So it seems like quite a complicated question, but let's break it down, and that's why it's question number 45 here. So let's start off with at the start. So at the start, in terms of the 2p's and 5p's, we know that we've got 2p's and there's 5p's. And we know the ratio of 2p's to 5p's is 7 to 3. Now we don't know how many there are. There could be 7 2p's and 3 5p's. It could be 14 2p's and 6 5p's, 21 2p's and 9 5p's, and so on. But what we know is it's in this ratio. So what I'm going to do is I'm going to let the number of 2p's be 7x, and I'm going to let the number of 5p's be 3x. Because we know there's going to be 7 times a number and 3 times a number. It could be 7 times 1 and 3 times 1. That's 7 and 3. It could be 7 times 2 and 3 times 2. So that'll be 14 and 6, and so on. Okay, so we've just let it be 7x and 3x in terms of the number of 2p's and 5p's in the bag to begin with. We're then told some coins are added. We're told that 2 2p coins and 8 5p coins are added to the bag. So let's add 2 to the number of 2p coins. So the 7x, we're adding 2, so that'll be 7x plus 2. We're just adding 2 more coins in. And then in terms of the 5p coins, there was 3x of them. We're going to add 8, so that'll be 3x plus 8. So that's fantastic. We now know expressions for the number of 2p and 5p coins in the bag. Now we don't obviously know what x is yet, but hopefully we'll be able to find that. So we've now got expressions for the number of 2p coins and 5p coins in the bag. Now if we carry on, we're then told the probability that a coin picked at random being a 5p is equal to 2/5. So let's find an expression for the probability of a 5p. So let's find an expression for the probability of a 5p. So in terms of the probability of a 5p, it'd be the number of 5p coins in the bag, which is 3x plus 8, the number of 5p coins in the bag, over the total. And in terms of the total number of coins, that'll be, if we add these together, 7x plus 3x is 10x, and 2 plus 8 is equal to 10. So that means the probability of picking a 5p coin from the bag will be 3x plus 8 over 10x plus 10. So that's fantastic. We've now got an expression for the probability of a 5p coin, but we're also told that that's equal to 2/5. So hopefully now we can then solve this equation and find out what x is, because we know that 3x plus 8 over 10x plus 10 is equal to 2/5. And if we solve this equation, we can find out what x is. Okay, so we're now going to solve this equation. There's a few approaches we could use here. We've got a fraction equals a fraction. I like to solve equations like this using cross multiplication. If you've got a fraction equal another fraction, this numerator times that denominator will be equal to that numerator times that denominator. Now, you don't have to use that approach, but that's just one approach that would work. Another approach would be to times both sides of the equation by 5 to begin with. So you'd get, if you times this side by 5, 15x plus 40 over 10x plus 10 equals 2. And then you could times both sides of the equation by 10x plus 10, and that'll give you 15x plus 40 equals 20x plus 20, and then you could solve that equation. So you could get rid of the denominators by multiplying both sides of the equation by one denominator, and then multiplying both sides of the equation by the other denominator, and that's totally fine. But a bit of a shortcut is that cross multiplication, that numerator times that denominator equals that numerator times that denominator, and that works whenever you've got a fraction equaling another fraction. So let's do that. And you're going to get the same as what I just explained anyway. So if this numerator times that denominator, you'd have 3x plus 8 times 5, so that'll be 15x plus 40. And then this numerator times that denominator would be 20x plus 20. So we've just times that numerator by that denominator, and that numerator times that denominator. Now we just need to solve this equation. So let's take away 15x's from both sides of the equation to get rid of the lowest number of x's. So on the left hand side we'll be left with 40, and on the right hand side we had 20x plus 20. We're taking away 15x's, so that'll leave us with 5x plus 20. Now we want to get the x on its own, so let's take away 20 from both sides of the equation. So on the left hand side, 40 take away 20 is equal to 20, and the right hand side would be left with 5x. And then if we divide both sides of the equation by 4, we're going to get that x equals 4. So we'll find out what x is. So now we'll find out what x is, we can go back up, and we're asked how much money was originally in the bag. Well, I'm just going to change colour ink here to blue. We know that x is equal to 4, so x is equal to 4. So if we know x is equal to 4, we can substitute that in. 7 times 4 would be equal to 28. So there's 28 2p coins in the bag to begin with. And 3 times 4 is equal to 12. So that means there was 12 5p coins in the bag to begin with. So let's work out how much money that is. 28 multiplied by 2p would be equal to 56p. And 12 times 5p is equal to 60p. So that means there's 56p in 2p coins, 60p in 5p coins, and if you add them up, that's equal to £1.16. So that means there was £1.16 in the bag to begin with, and that's it. So just to recap in this question, we were given the ratio of the number of 2p to 5p coins in the bag. We didn't know the number, so I just let it be 7x and 3x, 7 times a number and 3 times a number. We then knew that 2 2p coins and 8 5p coins were added to the bag, so I just added the 2 and the 8 to the 7x and 3x. We then knew a probability of picking a 5 coin was equal to 2/5, so I found an expression for the probability of a 5p coin, which was 3x plus 8 over 10x plus 10. I then put that equal to the 2/5 and solved that equation. I use cross multiplication. You don't have to. You can just multiply both sides by that denominator and then both sides by that denominator, but it gives you the same thing anyway. Solve that equation and find out that x was equal to 4. And then once we found x was equal to 4, we done 7 times 4 meant there was 28 2p coins, which is 56p, and 12 5p coins, which is 60p, and added them together to get 1.16. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on probability. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. Also, if you know anyone that needs any extra help with their maths, please recommend Corbettmaths resources to them. Hopefully that'll be able to help them out. Also, just to mention, if you need any extra help on your probability topics, if you go to Corbettmaths and watch video numbers 244, 245, 250 and 251, they're going to be useful videos for you as well. But I really hope you found this video useful, and if you have found it useful, please like and please subscribe to my YouTube channel. Thank you. Cheers. Bye.